Okay, just a bit then on pulley systems. Usually pulleys will be smooth, so that we know that means frictionless. Therefore the string on either side will have the same tension. Strings and pulleys will be light. Their weights will be negligible. Finally, strings will be inextensible. Therefore the connected particles will act as one particle. That means as one kind of goes up, the other one goes down, and so on. Particles of 5 kilograms and 2 kilograms are attached by a light inextensible string which is passed over a smooth pulley. System is released from rest. Find the acceleration, the distance by the first 3 seconds, blah blah blah, the force exerted on the pulley. So let's take a wee look. For almost all mechanics problems, I want us to draw a clearly labelled force diagram showing all the forces acting on these. So we are going to have that. That is 5 kilograms. And then we're going to have this one here, and this is 2 kilograms. So it's up to us to realize that it's going to travel this way. This is obviously a lot heavier than this one, so this is going to go down and this is going to go up. So our acceleration goes this way here, and it goes this way here. We have to find acceleration, we don't know it, so we're just going to call that A. And we're looking at the forces that are just acting on these two particles here. Alright, so we want to find out what force is acting on this. So this moves down, so the thing that's pulling it down is its mass times gravity, so that's going to be 5g, that's 5 times 9.8, and going this way then it's going to be the tension. There are forces acting on the pulley, we're not worried about those knowledge yet. On the 2g one, sorry 2 kilogram one, it's 2g acting down, and then there's a tension going up. So we're going to do F equals ma for both of these and see how we go. First of all then for their 5 kilogram, and again making things nice and clear to the examiner, it's a 5 kilogram one I'm dealing with here, and I'm doing F equals ma. Right hand side first to make me feel better. Our mass is 5, the acceleration we don't know, so we're writing 5a. What forces are acting on this in terms of direction it's travelled? It's going to be this, take away this. The direction of acceleration is this way, so that one's a positive one, that's slowing it down, so it's going to be then 5g take away t. I'm going to call that equation 1. And next the 2 kilogram one, I'm going to F equals ma. Right hand side first, it's going to be 2a. What forces are acting on this? So it's going this way this time, so it's going to be t take away 2g. I'm calling that equation 2. If I bring those two equations together, let's see what we end up with. So I'm going to have 5g take away t equals 5a, t take away 2g equals 2a, and the standard thing to do is add these two equations. 1 plus 2, again the right hand side is easier. This plus this, adding all the right hand side gives me 7a. If I add everything here on the left hand side of both of these, the t's disappear. I hope you can see because there's a minus t there and there's a t there, and then adding those I end up with 3g. So my acceleration, then I'm going to divide by 7, so a is then 3/7 of g, and that then is ms to minus 2. If you put that into your calculator, do a couple of decimal places, that's the one significant figure surely, ms to minus 2 there, but this would be a handier number to kind of keep using in terms of what we need. So that's what we have there. Part B then asks us, find the distance moved by the 5 kilogram mass in the first 3 seconds of motion, assuming neither particle reaches the pulley or hits the ground. It's the same as the 2 kilogram mass, it's a funny way to ask it, but it travels this way, and assuming then that it doesn't hit the ground, how far then is it going to travel? So that's going to be a UVAS question first. So this is part B. As with all of these, I do U, V, A, S and T, and because it's due to gravity, I'm going to pick the direction to be positive and pick that. It starts from rest. U is 0. Distance move, we don't know. Our acceleration, we've just worked it out, so it's 3/7 g. Distance is what we want, and our time then in this case is going to be 3. So we're going to use S equals, so I'm going to write flat here, ut plus a half a t squared. S equals 0, which is handy, so it's half upon 3 sevenths G all upon 3 squared. If you put that into your calculator and tidy it up to 3 significant figures, you should get then 18.9 meters. The final thing we're asked for in this then is find, also it says, the force exerted on the pulley. We haven't considered really too much of this at all, but the way it works out for us as follows. As you can see, there's these two forces going up. We haven't looked at any forces on the pulley, but if there's two going up there, there's actually two going down this way here as well. So this is pulling on the pulley, this is pulling on the pulley, so it's just going to be 2t. I don't even know if I've worked out the t from the previous one, did I? I haven't even worked that out yet. That's a disaster. So let's work out our t then as we're working out in kind of part C. So it said find the acceleration. So first of all, we're going to work out our t, and we are going to use this one here. So we're going to have t, take away 2g equals 2a, t equals 2a plus 2g. So t equals, it's that 2a, then ends up being 8.4 and then 19.6, so that ends up being 28 newtons. So that's kind of from the previous bit. You're often asked to work actually that out at the start, and then force on pulley equals 2t, which is equal to 56 newtons. Sometimes the pulley, they're not kind of both parallel to each other. Sometimes the pulley acts like this, and there's a tension coming off like this, and there's a tension coming off like that. And in that case, then you need to resolve. So we'll be doing that a little bit later on, but that answers that bit then from there.